I would say, I mean, the way that it's worded, D is okay. But I would think A would be better because it shows you every hour. Okay? All right. So you guys should be on page 509. 509.
This thing's heavy.
And that should say explore measures of variability. So we are going to find and use the range, the interquartile range, and the median. I'm sorry, and the MAD. I'm sorry. All right. So it says one measure of variability is the mean absolute deviation. So it says the ages and years of the two teams of cyclists at the Tour de France are shown. 29, 32, 33, 26, 22, 32, 22, 23, and 24. And then team 2 is 27, 33, 31, 29, 26, 30, 29, 33, and 32. So the first thing, because if you go down and look, we have to find the MAD. So the first thing we have to do is find the mean. So to find the mean, remember, we have to add 29, 32, 33, 26, 22, 32, 22, 23, and 24 together. So add those together. And when we add those, for the sake of time, I get 243 divided by 9.
Miss Lavelle, why do you always say for the sake of time?
Because if I sit here and wait for you guys to add those together, it takes away from the instructional time.
Good one.
Okay? All right, so then 9 into 243, 509. All right, so 9 goes into 24 2 times, right? I actually need to move that up because I didn't give myself enough room. All right, so that goes in there 2, which is 18. So 18 minus 24 is 6, right? Bring down the 3, so 9 goes into 63 how many times?
At least.
Well, 9 times what is 63?
7.
So the mean is 27. All right? Then we add all of this. 27, 33, 31, 29, 26, 30, 29, 33, and 32. And I get 270 divided by 9. So 9 into 270. So I think it's 3. 9 times 3 is 27. Yep.
The answer would be 30 years.
Your answer is correct. 30 years.
Wait, how much wait, 1 second. Okay, that just freaked me out. I'm like, wait, how long have I been on the roller? What just happened?
Okay, so now we have to find the MAD. Okay, so remember, we have to subtract each one of these. So I'm going to do it right. I'm going to try to squeeze it right here, okay? So team 1. So I'm going to do 29 minus 27, which is 2. 32 minus 27 is 5. 33 minus 27, 6, right? 27 minus 26 is 1. 27 minus 22 is 5. 32 minus 27, 5 again. 27 minus 22, one more 5, and then 27 minus 23 is 4, and then 27 minus 24 is 3. All right, so now we're going to add all of that together. So 2 plus 5
equal 35.
plus 6. Add it again.
Wait. 5, 10, 15.
So here, we'll do it on a calculator. So 2 plus 5 plus 6. Oh, that's not what I wanted. Should have been plus 1, right?
32.
And then I can do 5, 10, 15. So I'm going to do plus 15.
Don't forget 20.
And then plus
The
the
other part.
7. So we should get 36. All right, so the MAD of Team 1, what's 36 divided by 9?
4.
Yep. So the MAD of Team 1 is 4. So that's what we're going to write right here. Okay, then we're going to do Team 2. All right, so 30 is that mean. So 30 minus 27, 3, right? 33 minus 30, what do we get?
3.
3 again.
3.
So 30,
2.
hold on, I got to write it differently. So this,
33 minus 31.
so 31 minus 30, right? That means 30.
Oh.
So that is 1,
1.
okay? 30 minus 29, yep, 1 again,
4.
yep.
0. 1. 3. 2.
All right, I can't write that fast, so hold on. And then 33 minus 30 is 3, and then 32 minus 30 is 2. Yep. All right, so add those up.
16.
Add them again. So 3 plus 3, and then 4, 5, 6, 7. So plus 7, plus 5. I get 18.
Wait. What's that? 3 plus 3 plus 3 plus 9 plus 5 equals 15.
14. 9 plus 5 is 14.
I added 3 plus 3 plus 3, which equals 9.
Gotcha.
Plus 1, which equals 10. Plus 5, which equals 5. Plus 2. Wait a minute. So I got the same numbers as you.
Look,
3,
look,
1,
cross them off as you go, William. So 3, 3, and 3. Right? So we've added those, we get 9.
Yes.
Okay?
Plus 1, 1 plus 4 equals 5.
Okay. All right, but what about this one? So 1 plus 4 is 5, 6, 7,
Then you add the
8, 9.
you add the 1. see it in the... Okay, 1 second. I did 3 plus 3, which equals 9, plus 1, which equals 10, plus... Miss Lavelle?
Yeah.
I can't do my work right now because I don't have my book currently because I forgot it at my house.
Okay. You can do it on, well, we're just doing the lesson today anyway. All right, so William, 9 plus 1 is 10.
Never mind.
You got it? Okay. So what is the MAD? 18 divided by 9. 2. So we're going to put that here. All right. So it says compare the MAD of Team 1 to Team 2. What do the MADs tell you about the two teams' ages?
That it's Team 1 is 4 years, but Team 2 is 2 years.
Yep, so Team 1 has a greater MAD. Right? So that means...
I said Team 1 is older.
That means they have more variability. So that means that variability is a bigger spread. So variability means bigger spread from the mean. All right. So it says, if the distance between a cyclist's age and the team's mean age is less than or equal to the MAD, the cyclist falls within the MAD. For Team 1, list the ages that fall within the MAD. So what that means is if I was going to put this on a graph, right? So if we graph Team 1, right? So let's say 29, 32, 33, 26, 22, 32, 22, 23, and 24. All right, so the mean was here. That's the mean. We need to find the points that are within the MAD. So what we do is you take the mean, which was 27, and we add the MAD. So the MAD was 4. Okay? So when we
31.
Right. So when we add the MAD and then we subtract the MAD, so I'm going to take 27 minus 4. That gives me what?
That gives you 23.
Yes. So points that fall between 23 and 31 are within the MAD.
And it asks us in the turn and talk, what is the difference between the MAD and the median?
Yep. All right. So here is my box, right? So it says between 23 and 31. So my box should look, yep. So any dots that fall between my box are considered to be within the MAD. So we have number 23, right? 24, 26, and 29. So these are the values that fall within the MAD, because that's what it has. List the ages that fall within the MAD. So these are the ages that fall within the MAD. All right. So William started talking about the turn and talk, but I wasn't ready for it yet. So it says, what is the difference between the measure of center, such as mean, and the measure of variability, such as mean absolute deviation? So what were you telling me, William?
So it asks us what is the difference between the measure of center, such as the mean, and the measure of variability, such as the absolute devastation. Well, you subtract 27 by 4, which would equal our answer.
Yeah, but that's not telling me what's the difference between the mean and the MAD. So what did I tell you? What type of measure is the mean?
Measure of center.
Yep. And when I find the mean, what am I finding?
The center.
The center, right? The center of all the data points. Okay, so the mean is the center of all the data points added together, right?
Yes.
Okay, and the MAD, T-O-G-E-T-H-E-R. Okay, the MAD is the average of the points away from the mean. So it's variability. It's telling me the distance, right? So this is distance.
One second.
All right. Am I good?
Yes.
Gia, are you good?
I don't have my book, remember?
Oh, okay. Well, I didn't know if you were following along on the actual NT math. All right. So the other measure of variability are range and interquartile range, and we've already talked about these. So remember, the range is the difference between the greatest and the least.
I prefer paper copy.
Okay.
Other than electronic.
Okay. Is the difference between the greatest and the least values. The interquartile range is the difference between the upper and the lower quartiles. Okay? So let's look. The range of store A. The highest number is 300. The lower number is 120. So 300 minus 120 gives me what? What does it give me? Actually, I didn't need to borrow on that. Hold on. So I don't need to borrow here, so that's 0, right? So that becomes 10, and that becomes 2. So 10 minus 2 is 8. Yep, and 2 minus 1 is
1.
Yep. So the range of store A is 180. So it is $180. All right, store B, the largest number is 250. The smallest number is what? What's my smallest point? I'm pointing at it.
100.
Yes, my smallest point is 100. Okay, so 250 minus 100 is what?
150.
Yep, 150. So the range for store B is $150. All right, the interquartile range. So this is the upper quartile, right? So this is UQ, and this one is LQ. So that would be 230 minus 180. 230 minus 180. And what does that give me?
50.
So 13 minus 8 is 50. Yep.
Wait, you said 13 minus 8 is 50.
Well, 5, so it gives me 50. All right, store B. Upper quartile is 200. Lower quartile is what?
The lower quartile is 130.
Yep.
Which the thing would equal 170. No, 70 actually.
Yep, should be 70. All right, so now we're going to compare them. So store A has a greater what?
Greater amount.
What did we find up here?
Greater range.
Yeah. But store B has a greater what?
Amount. Or IQR.
Greater interquartile range. All right, so it says, from the box plots, can you tell the exact price of any of the routers at the two stores? If so, explain how. So if I was to go back up here, do we know any of the exact prices of the routers?
Can you please say that again?
So if I'm looking at my box plots, do I know the cost of any of the routers?
You do.
Which ones do I know?
You know the lower quartile and the higher or upper quartile.
Okay, I don't know the values of it, right? Because remember, this is the median. But what do I know?
It's between 120 and 300.
What is 300 and 120?
420. That's it.
What do we call those?
Range. Certain ranges.
What do I call that?
A greater value.
The greatest value. And then what do we call this one?
The least value.
Yes. So we know that the cheapest router is $120. We know that the most expensive router is $300. So this would be yes. We know the cheapest router and the most expensive. Right? Everything else we don't know because it's all medians of data. But we do know the cheapest and the most expensive. All right, am I good?
Yes, ma'am.
All right, so the last example. So it says the number of visitors each day last week at a train exhibit hosted by a local museum were 29, 3, 45, 33, 30, 38, and 25. I can read, William. Thank you. I can get it. I appreciate your help, though. Let me know, Brianna, when you're done.